Percentage yield and purity of sample. When we are talking about yield, we are talking about the product form. So percentage yield means percentage of the product. The formula for percentage yield equal to actual yield over theoretical yield. The actual yield, the mass or number of mole that is formed after the experiment. Meanwhile, theoretical yield is the mass or the number of mole of the product that we calculated from the chemical equation times by 100. So this is the formula for percentage yield. Theoretical yield, the amount of product predicted by the balance equation when all the limiting reactant has reacted, while actual yield, the amount of product actually obtained from the reaction. So basically it's from the experiment, from the actual experiment. Usually the actual yield is given in the question, whether mass or number of mole. If 3.7 gram of sodium metal and 4.3 gram of chlorine gas react to form sodium chloride, what is the theoretical yield? If 5.5 gram sodium chloride was formed, what is the percentage yield? First, we have to find the theoretical yield. We know that the mass of the sodium metal and chlorine gas. So we have information for both reactants. We need to compare with the product, but before comparing with the product, we need to find the limiting reactant first. So in order to find the limiting reactant first, we need to find the number of mole of sodium and chlorine gas. So the number of mole of sodium, 0.1609 mole. Number of mole of chlorine gas, 0.06056 mole. Now, we have to find the limiting reactant of this reaction in order to compare or to get the number of mole of sodium chloride. 2 mole of sodium equivalent to 2 mole of sodium chloride. So we have the actual number of mole of sodium, 0.1609 mole, equivalent to 0.1609 mole of sodium chloride. 1 mole of chlorine equivalent to 2 mole of sodium chloride. 0.06056 mole of chlorine produces 0.1211 mole of sodium chloride. If we compare these two number of mole of product, the number of mole of product produced by chlorine is fewer than the number of mole of product produced by the sodium metal. So chlorine is the limiting reactant. Now we use the actual number of mole of chlorine, 0.06056 mole of chlorine, equivalent to 0.1211 mole of sodium chloride. We must compare with chlorine because chlorine is the limiting reactant. In order to get the number of mole of the product, we want the theoretical yield, means we want to identify the mass of the product. Mass in theory, so means mass the one that we got from the chemical equation that we compare the number of mole of each of the substance. So use the number of mole of sodium chloride times by the molar mass of sodium chloride. The answer is 7.08 gram of sodium chloride. This is the theoretical yield. Next, we want the percentage yield. Use the formula of percentage yield, actual yield divided by theoretical yield times 100. So the actual yield is given, 5.5 gram is given, and then the theoretical yield, 7.08 gram of sodium chloride. The percentage yield is 78%. Purity of samples, mass of pure substance divided by mass of impure sample times 100. So purity of sample is mass percentage of a specified substance in impure substance. Usually mass of pure substance is smaller than mass of impure sample. An impure sample of solid sodium carbonate is allowed to react with 0.1755 molar HCl. We have the molarity of HCl is 0.2330 gram. Sample of sodium carbonate requires 17.85 ml of HCl solution. Given the mass of sodium carbonate and the volume of HCl solution, we want the purity of sodium carbonate. 0.233 gram sample, this is the mass of sodium carbonate impure, the impure sodium carbonate. And then we have the volume of HCl. We want to know the purity of sodium carbonate. Now, from the equation given, we can get the pure sodium carbonate number of mole and then convert it to mass, and then you can identify the purity of the sodium carbonate. First, convert into number of mole. We have the molarity, we have the volume HCl, so we can get the number of mole of HCl. So now we have number of mole of HCl, you can compare with number of mole of sodium carbonate. 2 mole HCl produces 1 mole sodium carbonate. We have 3.13 times 10 to the power of negative 3 mole HCl. Cross multiply to get 1.57 times 10 to the power of negative 3 mole sodium carbonate. Now you can convert this number of mole to mass. Mass of the pure sodium carbonate, 0.166 gram. Then you can find the purity of sodium carbonate. Mass of sodium carbonate, the one that we got from the equation, the one that we compare with HCl equation. Then mass of sample given in the question times by 100, get 71.2% sodium carbonate. Example for redox titration. A 0.376 gram sample and iron ore is dissolved in acid. So mass given is mass of iron impure. This is impure iron because sample of iron ore, impure iron. The iron reduced Fe2 plus and then titrated with 41.25 ml of 0.0214 molar potassium permanganate. Determine the percentage of iron by mass in the iron ore. So we want the purity of iron in the iron ore. The equation given is the redox equation. Fe2 plus react with MnO4 minus, produce Fe3 plus Mn2 plus. If you notice, it's not a balanced equation because you have 4 oxygen on the left and no oxygen at all on the right. So you have to balance this equation. In order to balance a redox equation, you must follow the step-by-step redox reaction equation balancing. So after you balance the equation, you get 5 Fe2 plus MnO4 minus plus 8H plus, produce Mn2 plus 5 Fe3 plus 4 H2O. The number of mole of MnO4 minus, because we have the volume and the molarity of KMnO4. We don't have the KMnO4 in this equation, but KMnO4 represent MnO4. So the number of mole that we can get from the molarity and the volume of KMnO4 is the same as the number of mole of MnO4. So just find the number of mole of MnO4 minus. it's 8.828 times 10 power of negative 4 more MnO4 minus. Now, when we have the number of more of MnO4 minus, you can compare with the number of more of iron to get the actual number of more of iron, and then you can get the mass of iron. So 1 mole of MnO4 minus equivalent to 5 mole of Fe2 plus, because it's reduced to Fe2 plus. So 8.828 times 10 to the power of negative 4 mole MnO4 minus equivalent to 4.414 times 10 to the power of negative 3 mole Fe2 plus. This is the number of mole that we got when we compare with number of mole of MnO4 minus. So if you have this number of mole, convert it to mass, get 0.247 gram. This is the pure iron. The mass of Fe2 plus, same as the mass of iron, and it's the pure iron. We want the percentage of iron in iron ore, means we want the percentage purity. So we have the impure mass and the pure mass. So mass of pure iron in the sample divided by mass of impure iron ore times 100 equal to 65.7%. Thank you.